Okay. So how about my voice? Is it clear for you? Because today I run my class in our lab, robotic lab. So I
Clear.
hope
Clear,
okay.
Doctor.
Clear, Doctor.
Okay, untuk figure ni, boleh nampak ah?
Yes.
Boleh baca ah? Okay. So this is DH method lah. So Denevit Hettenberg. So DH method is the improvement from the homogeneous transformation metric method lah for kinematic. So in DH method, they try to simplify the calculation. Compare if you use a homogeneous transformation metric, you need to multiply. If you have many join, 4 join, that means you have 4 metric. So depend what type of join, rotation or translation. So your metric always need to be calculated if one of the motor is changing the position. So if you have 4 join, that means you have 4 metric. So 4 metric must be calculated every time your joint is moving. But using DH method, so the calculation has been simplified. So So you already combine that all 4 metric into a single metric 4x4. So that means you put your metric inside your controller. So your robot will calculate only 1 metric because it's already simplifies the metric into 1 4x4 metric. Compared to the homogeneous transformation metric, the speed of your robot will be higher lah using DH method because you already you use a simplified metric lah. So your controller will use a less time for calculation. Compare homogeneous, you need to calculate every time your robot move using 4 metric. If you have 6 joints, so you have 6 metric need to be calculated. If you have more than that, so your competition will be lower, slower. But after you do a calculation, sorry. After you do a simplification of metric, you also get 1 metric also. Sorry. For homogeneous transformation metric, you multiply the calculation, you multiply the metric, so you also have 1 metric. Oh, sorry, it's the same. So homogeneous transformation metric, after you multiply your all 6 metric, you also get 1 metric, single metric for your controller. DH method also, you have 1 single metric, but based on the simplification of solving the metric, so DH is faster lah. DH is faster, but you need little bit imagination on 3D to solve DH simplification metric. Okay, if you open the book or internet, when you write down DH method, they always show this figure. So what is this figure mean? This figure mean the joint of the robot arm or joint of mechanical. Doesn't mean only robot arm, maybe a mechanical part. You design any mechanical part, so you can use DH method. For example, this is joint 1, this is join 2, and this is join 3, for example. So n is variable. Maybe you start from 0, join 0. This is 0 plus 1 is 1. 0 plus 2 is 2, something like that. And then this is join 1. So you have rotation of theta. So if your rotation at z axis, so your name is theta. Theta. If you rotate on x axis, your angle will be named as alpha. If you have motion on along z axis, so we call d. If you have motion along x axis, doesn't mean motion. Maybe you have the link, robot arm link. So that along x axis we call A. A for x, alpha for x. Alpha is angle for x axis. A, your distance or link between joint along x axis. And then for z, the rotation along z axis is theta, and the length of z, maybe your arm length or your traveling length, we call d. So this is standard name lah. Theta and d for z, alpha and a for x. So in DH method, we not consider y because y will be calculated automatically. So once you when you calculate z and x, so automatically in DH you will get x at this coordinate. This is special for DH. So this is the parameter that is used in the DH, which is theta, d for z, alpha and a for x axis. For this figure, do you have any question?
No, clear, doctor.
Okay. Okay. Step to assign a local frame. All joint represented by z-axis. This one what I explained before. Direction of z-axis, revolute. Revolute. Right hand rule. So we use right hand rule. Prismatic along linear motion. Okay. Prismatic, if on z-axis, revolute is theta. Prismatic is d. So the index number z for joint n is z n minus 1. Joint variable, okay, revolute we call theta for z, and prismatic we call d. Okay, common number between, okay, and then this is for x. For x, A for the prismatic, and okay, and the other one is alpha, yeah, alpha for x at this. Okay, this example lah. If you found a rotation, so this one after you combine all these, so how you define the DH method using DH method lah, example. So if you have rotation along z axis, so along z axis, so we call theta. So you use your homogeneous transformation matrix rotation z. So this one you use back your homogeneous transformation matrix. So we have three formula. We have rotation x, rotation y, and rotation z. And the other one, translation. So in homogeneous, you have four matrix formula that you apply. So that formula will be applied in the H also. So in this case, you are rotate z axis. to rotate z-axis. So theta will be variable lah. So maybe 90 degree, maybe 180 degree, or 10 degree. So but what we see here, there are rotation on z-axis. So maybe you have your robotic arm have a joint. Your joint have rotation on z-axis. And then you have a length of robot arm, a link. The arm we call link. So link is D, for example. So translation. So if you have translation on Z, so in this case, X is 0, Y is 0 lah. So this one you use a translation metric from homogeneous. Then you combine it with rotation. This A is for X at this. So this is a translation. Maybe your arm have a linear motion, or maybe your arm link. So depend lah. So maybe this is your robot design. You can extend or retract the arm, or maybe this D is your link length of your arm. So between these two joints, you have a distance between these two joints. This along x-axis we call A. So you have a value variable for X and 0 for Y and Z. This is combination. When you move this line to on this line, so you can see like this. And then you have rotation on X. Just now you have translation, and then you have rotation on X axis. So you need to apply rotation metric from homogeneous. Later I show you the metric. Okay. So after this translation, so this is the metric that will be used. So this is moving frame. When you going to calculate for moving frame, so you must put your metric from left to right. Moving frame, that means you want to map the frame from position 1, position 2, position 3. So you want to map the frame. So when you want to map the frame, so you need to put your metric from left to right. But you can calculate left to right or right to left. But you need to arrange your formula from left to right. So after you multiply, so you get this single metric. So in DH, first you need to find out, for example here, you need to find a DH parameter table. So here theta is on Z axis rotation. D is your prismatic motion, or not motion, is prismatic length on Z axis. A is your distance for your X axis, and alpha is your rotation on X axis. So because you have this robot arm has 6 joints, so you have 6 rows. This is a right hand rule. We call frame. Right hand rule frame. So you have rotation for first joint in this rotation. So that means your Z is vertical. So So how we develop this? So for example, here you can see here. So because your rotation here is X and Y, so your center is Z. So you rotate along Z axis. Rotate along Z axis. So at Z, so you have rotation theta 1 for this first joint. You have rotation. So you have motor here to rotate at theta 1. And then we see the difference between frame 0 and frame 1. Frame 0 and frame 1. So what the difference here? So x0, now x1, first x0 in this direction. Now a second frame or x1, we start from x0, frame 0, and then this is frame 1. So frame 1 change to right direction, from left to right. So that means you have turned your direction. And then you see Z0 to Z1. So that means there are some theta have been changing. Theta have been changing, and X also have changed, because from Z0 from vertical to horizontal Z1, and then X0 from left to right. So Z you have theta 1, and then you also have rotation on alpha 90 degree. So you can see your Z is vertical and then change to horizontal. That means you are rotating your X axis. You are rotating X axis. For this example, rotating 90 degree. 90 degree. So rotate 90 degree. So that's why frame 0 vertical, and then frame 1 horizontal. So horizontal 90 degree. Because you see the joint here, how do you connect the joint? So the joint here, your Z should be horizontal. Okay, from frame 1 to frame 2. Frame 1 to frame 2, you see Z is parallel. Z parallel, that means there are no changing, no rotation on X, because your Z is parallel. But you need to see your X. See your X. So they are not changing on X, but you have a distance of prismatic. Prismatic, for this case, this one is the length, your robotic arm length. So between this joint to this joint, we call A2. So you have joint A2. And then from joint 3 to joint 4. Joint 3, So you have length A3. So you have A3. And then you have rotation on joint 3 because this is a revolute. So you have theta 3. This is Z. So that's why your rotation on theta, not alpha, theta. So you have rotation on theta, on Z. Okay, join 4. Join 4. So you have, join 4. You have rotation on theta 4 because you are rotate on Z axis. Then you have a distance A4. Distance A4. And then you have negative 90. You have a negative 90. Why negative 90? Because you see Z here from horizontal and then you turn to vertical. So horizontal to vertical. That means you are rotate X axis. You are rotate along X axis. So because you see from this view X, so you see that your rotation is turned clockwise. So from Z3 to Z4, you are rotating clockwise. Clockwise means negative 90. Negative 90. So because this is, you design your robot this way. So you join from horizontal to vertical, something like that. Vertical to horizontal, horizontal, horizontal. And then you put join number 4, vertical. So this is your mechanical design. And then join 5, you have rotation here. And then you have, you see your Z4 from vertical go to horizontal back. From vertical Z4 to horizontal. That means you are rotating X 5, 90 degrees. Because this way, if you're rotating this way, that means you're rotating counterclockwise. Counterclockwise. So you get 90 degree. But this, you have rotation on theta, Z axis. Join number 6. This join number 6, so you don't have any rotation, but you have rotation on gripper. Join number 6. So now you have a complete DH parameter table for 6 degree of freedom robotic arm. They have all revolute joint. When you have all revolute joint, so you have all theta rotation. Theta rotation. Because in this case, all rotation you have changed to Z. So Z, so all this Z axis rotation. And this you can see here, X, your A and your alpha is related to your design of your robot. So your robot design. So how long your robotic arm length, what is the length of your robot link? You have 3 link here, and then you have your link, your joint is vertical or horizontal, so you have angle at your alpha. So then the second step, you need to multiply this value. This is one metric rotation, this is one metric rotation. This is metric translation. So you need to multiply rotation and translation. Okay, join 3, rotation and translation metric. So you see how many metric you need to calculate. Something like this. So this metric actually already multiply rotation metric Z and rotation metric X. So after you multiply, so you get this metric. So this from join 0 to join 1. And then join 1 to join 2. So you need to multiply rotation matrix Z. So this matrix Z. This one after multiplication. And then you have translation. Translation, that means you have two matrix. So that means I'm going to say that make it smaller. I'll go back to the slide. Okay. A1. This one theta 1. This is theta 1. This is 9. This is rotate. This is rotate Z. This one rotate X. Theta. So what is a rotate Z theta? So I need to go back to rotate Z. I can take here. So cos theta. But in this case, they didn't put theta because they try to reduce the complex number, the complexity of the number. So many number here. So they just put cos, cos 1, sin 1, so it's easier to calculate. If you write everything, it's too crowded, no? Too crowded. Sin theta, and this is cos theta. Cos theta. And this is 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. And then you have rotation on X. I hope I can get X here. If not, I need to go back to the homogeneous transformation matrix. Available here. So this is rotation matrix for X. So 1, 0, 0, 0, 0, cos alpha, negative sin alpha, 0, 0, sin alpha, cos alpha, 0, 0, 0, 0, 1. So after you multiply this, then you get A1. So suppose you get this. So they didn't put cos, they didn't put theta. A1 they put C1, C2, C3. So this one is actually C1, S1. So I just put theta first, but for the result I put C1. It's not, you didn't know where I get this theta, where I put this theta. So actually theta they didn't write here because they try to minimize writing on the matrix. So they just put C1, 0. Actually this is theta 1. So they just put 1 because they only one variable, theta only. Because alpha they got value. So theta is variable, they just write cos 1, sin 1. So, so you got one matrix. Then you need to do each of the row. Each of the row. For example, this rotate on Z multiply with prismatic. So you get this. And then A4 rotation Z, you multiply with translation matrix, prismatic, and multiply with rotation matrix on X. So actually this is, you need to multiply 3 set of matrix lah. 3 set of matrix. Rotation Z, translation X, rotation X. So 3 matrix. After you multiply, you get this. You see, you get the value of Y. Although you only consider Z and X exist, but after you apply homogeneous transformation matrix through this DH method through homogeneous transformation matrix, you will get Y value here. This is X, Y, Z. So we get Y value. Then you need to multiply all this matrix. Then after you get all this matrix for 6 row, you need to multiply all this matrix. But you need to arrange from left to right. Left to right, because you need to map. So left to right, from A1 to A6. So you get this a single matrix 4 by 4. So this single matrix you can put into your controller, robot controller, to calculate your position of your end gripper or end tool. So this is the last matrix that generated by DH method. So this is your final matrix. So this final matrix, if you have any change, so you have any change, this is fixed. Alpha is fixed because of your mechanical design. A is fixed because of your length of your arm. But you have changing on your theta because theta is moved by your joint. You have a motor or stepper motor at your joint. So theta will change. So this theta will be taking from your encoder. So your encoder. So your encoder will fit this value into your DH matrix here. So you will have a changing of your theta value. So when you have a changing on your theta value, so you will find your position. So this is your position, X, Y, and Z. And this is your rotation matrix. So you know your orientation of your gripper or end tool, and you know your position of your end tool refer to your world frame, your world reference frame, which is your base lah, your robot base. So this is your final, not that one, this one. This is your final, not this one, this is example. So this is your final, sorry. So this is your final between 0 to 1. 0, sorry, 0 to 6. So this is your final matrix after you multiply. So from join 0 to join 6. Join 1 to 6, but you start, the name is X as frame 0, but you have 6 join. But if you write in frame start from 0 to 5. So this is the metric that you put inside your controller, not before that. Before that is your general formula that to show you. But this is the formula that after you multiply all your matrix from A1 to A6, so you get a single metric for your specific robot articulated robot that has 6 degree of freedom. So you have 6 degree of freedom robot. So after you apply DH method, you will get a single metric that you will put into your microcontroller. If you design your robotic arm or gripper, this one change to other direction, then you cannot apply this formula. You cannot apply this formula because your x alpha, your alpha rotation on x axis are already different, so you cannot apply the formula that you get. So you need to calculate again. You need to calculate again to get this single metric for your controller, robot controller. Okay, until here. This one is 6 degree of freedom. Normally, I didn't give up to 6 degree of freedom. Normally, in your exam, is 3 degree of freedom. 3 is enough for a 45-minute calculation. It's not 6, because 6 degree of freedom, you need more than 1 hours lah to calculate this. 1 hours to define your DH parameter table. This is DH parameter table, and calculate this is more than 1 hours. So normally in examination, I will give 3 degree of freedom only. So that means 1 degree rotation and 1 degree is translation and the other degree is rotation, something like that. So not up to 6 degree of freedom lah. So it takes time for calculation. Normally 3 degree of freedom. So until now, do you have any question? This is general formula, not the final formula. Sorry, this is general formula. The formulas will you will get is this shape. So after you multiply this, the formula that specific for the articulated robot that 6 degree of freedom is this one. Where 90 and negative 90 gone? So because 90 when you do cos or sine, it becomes 0 or 1. So 0 or 1, that's why you didn't see here this 90 degree, because your 90 degree already changed to 0 or 1.
Doctor,
Yeah.
for A4,
A4.
macam Doctor determine yang if dia clockwise or bukan dia tak anti-clockwise for negative 90 and 90.
Ni A4 ni Okey, pasal apa dia negatif? Dah, betul? Okey.
Yeah.
Pasal apa dia negatif? Okey, A4 okay, Z4 ke Z5 is rotation. If we see from this view, so we see A4 is 3 to 4. Okay. join 4 is 3 to 4. 3 to 4. 3 to 4. Okay, 3 to 4. And 90 degree. Okay, 3 to 4. Okay, actually this one, how we write this? One actually from 0, frame 0 to frame 1. 0 to 1. That means Z0 to Z1. So we know that this rotate counterclockwise, rotate 90. Rotate counterclockwise. Because why? Because you see from X, when your eyes looking from X, you can see that you rotate counterclockwise, this one you need high imagination of 3D lah. So if you looking from X axis, you can see Z0 to Z1 is counterclockwise. Can you imagine that or not? If you looking from X,
Tak faham.
Awak tengok ke X kan? Kalau awak tengok ke paksi X ni, awak nampak Z ni berputar dari Z0 ke Z1 ni lawan jam.
Counterclockwise, betul.
Kan? Okey, kalau awak tengok nombor 4 ni awak nampak dari 3 ke 4, frame 3 ke 4. Frame 3 awak nampak dia horizontal kan? Lepas tu frame 4 awak nampak dia menegak. So dia berpusing. Awak kena tengok melalui X kan?
Oh, sudah berlawanan balik lah.
So clockwise. So bila clockwise dia jadi negative 90. Kalau in mathematics, if you rotate clockwise is negative. If you rotate counterclockwise is positive. So kalau nak faham, join one ni adalah changing from frame 0 to frame 1. Ni frame 0 to frame 1. Untuk yang 4 ni, from frame 3 to frame 4. Frame 3 to frame 4. So kita nampak dia rotate clockwise. Dia rotate clockwise. So clockwise maksudnya negative 90. In this case, normally they use right hand method lah. Right hand method tu. You need to remark on your finger. This is Z, this is X, this is Y. So and then you boleh move lah. So you nampak dia clockwise ataupun counterclockwise. Berpusing-pusing lah tangan nanti ni lah exam. But normally in your examination I give 3 at this only. 3 joint only. 3 joint. Not up to 6 lah. But I have more example. I will give example. I will take about 2 weeks after Raya. I will give more example on DH. More example. There are many type of robotic arm. There are many type. You have a spherical. You have what we call spherical. You have cylindrical robot. So all the example I will give in your class session after Hari Raya. So they are different of your homogeneous metric because of your link length and also your joint connection. Maybe one joint you change your direction from horizontal to vertical. Then you have different in this DH parameter table. Suddenly this joint you change your joint you change from this type of joint Z this direction, and then you change to the link here you change to Z vertical. So your DH parameter table will be changed. So when your DH parameter table change, then after you develop your A, you multiply each of the join here, DH parameter table row here. So you will get a different metric formula. So this metric formula will be specific for your robot design. So if you design one robot, a new robot, then you want the robot know the position and the orientation of gripper. So we use DH method. So we use DH method, and then after you multiply with the length of your robot arm and the joint angle, so you will get a specific metric for your robot. Ini senang lah. Kalau awak dah faham ni, if you understand this, you can do a master level. Because when you do a master level, you use a same formula, but you develop for your new, what we call, new system. Something like that, a new system. And then you develop your own metric, your own formula for your specific application for your master degree lah. If you want to continue your master degree in robotic, or maybe this one you not only in robotic, so you can apply this in your mechanical. So you have mechanical part that you have a joint, rotation joint. So and then you connect your mechanical maybe 90 degree, maybe 35 degree joint. So not perpendicular 90 degree. Maybe you connect your joint 45 degree. So you want to know the end of your end of your mechanical part. Where is the position? Maybe you do a crankshaft, something like that. You can apply this also. So you want to know your crankshaft moving up, down, kan? So you want to know the position of crankshaft. But your important part is your encoder. So if your encoder give a correct position of your rotation, so you will get a correct position of your crankshaft, something like that. Not only apply on the robotic arm.
Doktor?
Ya.
Kalau yang rotation tu terbalik, boleh ke?
Terbalik, yang mana? Rotation ni
kalau macam frame 1 dan 5 I bubuh negatif, yang frame 4 jadi positif?
1 dan 5 kalau terbalik. Kalau 1 terbalik, sini kalau saya rotate 0 to 1 adalah, kalau saya tengok part CX dia adalah positif. Kalau awak letak negatif, masa dia duduk belah sana, duduk belah belakang. Tak betul boleh kot.
Kalau macam I tak tahu depan belakang, nanti I tengok dari belakang pula.
Tak boleh, kita kena ikut right hand rule tu. Right hand rule tu kalau kita tengok daripada X kan, ni X kan, ni Z. Okey. Okey, sekarang awak punya Z duduk atas, X awaknya middle finger ni kan. So bila awak rotate macam tu, so maksudnya awak rotate adalah clockwise, counter clockwise. So counter clockwise. So counter clockwise adalah positif 90. Boleh lah kalau awak nak cuba, tapi saya tak tahu betul ke tak.
Sebab takut imajinasi tak bagus. Nanti
terbalik,
atas bawah tak boleh.
Tak boleh lah, awak kena ikut right hand rule lah. Right hand rule. Awak kena ikut right hand rule. Right hand rule betul je. Tapi untuk exam sikit je, 3 edges je. 3 join. Okey, ini contoh. Kalau you design awak punya, you design your robot, you have one joint, rotation joint, and then this one where we found out our angle lah. So first vertical Z, and then your Z become horizontal. So that means you have 90 degree X, something like that. 90 degree X. Yes, 90 degree X at this. Because you see this is Z and this is Z. or from Z vertical chain to Z horizontal. So they must be changing 90 degree. But you need to draw your frame lah. When you draw your frame, then you can exactly know your angle. Okay, this is linear motion. So this is prismatic. So this is rotation. This is rotation. This is rotation. So if you do your calculation, you do a DH parameter table, you will define this formula lah. But later I will show the detailed calculation for this example. So I have about 6 type of robot lah. 6 type of robot. They are contain rotation and prismatic condition lah. Prismatic joint. After Raya, I will show the example for different type of robot. This example of planar, 3-link planar arm. This one, we look from the top view lah, for example. So this is Z lah. The center is a Z. So we see from the top view. And you are moving, when you rotate your Z value, that means you are rotating X and Y axis lah. X and Y axis. Because in the middle, from the top view is Z. So you only can see X and Y. For example, this planar robot ni something like your Skara robot. Skara because the vertical is Z. So your robot only move X and Y. For example, for this frame 0, okay, frame 0 to frame 1, frame 0 to frame 1, so you have theta. So you have theta rotation, theta 1. This is taking from your encoder. And then you have length, your link length. So you have link length. From 0 to 1, from joint 0 to joint 1, or frame 0 to frame 1, frame 0 to frame 1. This is joint. This is joint, this is joint. But joint 1, we call frame 0. Frame 0 to frame 1, so you have distance A1. So you put distance X. A1. Because you not consider Y. In DH, you not consider Y. So this is X. And then from frame 1 to frame 2. So frame 1 to frame 2, you have also rotation theta, rotation on Z, theta. Because you don't have height. If you have height, then you have D. But now, for example, this example, you don't have Z distance. So you only have Z rotation. So you have theta 2, and then you have length, link length A2. And then from 2 to 3, you have A3 to gripper, you have A3. And then rotation at theta 3. So each of these row, you need to multiply. So you need to multiply rotation Z, metric Z rotation multiply with metric translation. This metric rotation Z multiply with metric translation, metric rotation Z multiply with metric translation. So after you multiply all that, you multiply from left to right, right to left, but you need to arrange it, the metric from left to right. A to 3, 1, 2, 3, to 1, 2, 3. From your metric, you need to arrange from left to right. After you multiply, so you get this metric specific for this robotic arm. If you change your length, so maybe you can change here, or maybe you need to recalculate back. For me, I think you need to recalculate back because this value is 6 value. After you multiply into a metric, so this value already mixed up. So if you change your length, your robotic arm length, so you need to recalculate back your metric because this metric is specific for this robotic arm. This is after multiply, you get this metric. So this is your position, orientation metric because it's containing your x, y, and z, cos and sine. This is your position metric. Refer to your base robot 0, 0, 0 coordinate. Your 0, 0, 0 coordinate, your base robot we call world frame, world reference frame. So you know your position of your gripper, refer to your world reference frame here. Orientation, how you know the orientation? This metric, 3 by 3. So this 3 by 3 metric is your orientation of your gripper. This spherical robot. So this is how you do inverse, but I have more example, but I will teach you all in after Raya lah. So after Raya, I take about 2 weeks. But in Hari Raya, you need to study homogeneous transformation metric because after second week after Raya, second week I will conduct a quiz regarding homogeneous transformation metric. Wait, I have example. One more example I take from the book related to this. This one you can screenshot. You can screenshot. Make it bigger. This example lah. This one is not clear, the example. So I take it from the book, it's more clear, the example. Something like this lah. Something like this. Okay, this is the robot. So you have revolute joint. And then you have linear motion. So this is two joint robot. Two joint robot. So you have rotation theta because your z value is perpendicular to our screen. So this is z perpendicular to the screen. And so your changing is your x and y axis. So once you rotate your z, so the changing is on x and y. Okay, revolute joint. This is joint 1. This is joint 2. Prismatic. But frame you call frame 0 lah. We call frame 0. Joint 1, frame 0. Joint 2, we call frame 1. This is your gripper. Okay, 2 point. So this is joint 2. So your theta here, you rotate this. This is base lah, link 0. Link 0, link 1, link 2. Okay. Okay, you can screenshot this. Can it readable or not? Boleh baca tak?
Boleh.
Boleh.
Boleh screenshot lah. Bila we assign a frame, so when we assign a frame, this type of robot, their frame is like this. So this is frame 0, frame 1, frame 2. So when we rotate this joint, so this joint, that means we rotate along z axis. So this axis will rotate lah, x and y. same origin. This is because they move, they split the frame. Some books, before the example, so they move this frame, they draw on the same frame because they want to see the changing of the theta. So they draw this axis on this frame. So you can see a bit crowded lah, a bit crowded. But from this book, they split out. So they split out. So this is frame 0, this is frame 1. So what do you see? We see that Z from this direction for joint 1 is perpendicular to our screen. Now Z change to horizontal. Change to right. Change to right. So from frame 0 to frame 1, this one is DH parameter table. Frame 0 to frame 1. So we have rotation on Z. And then we have rotation. This is not rotation. This is your mechanical design. You have X 90 degree. X 90 degree because this is Z0, this is Z1. So you looking from X, so you can see that your Z is rotation this way. Rotation this way. So rotation this way, if you're looking from X, that means it's rotate counterclockwise. It's rotate counterclockwise. So rotate counterclockwise 90 degree is positive. Positive. So now your Z become a right direction. And then from frame 1 to frame 2, we see any axis change or not. We see Z is similar, X is parallel, Z is parallel, Y is parallel. So there are no change on X. But you have Z distance. Z distance, a prismatic joint or prismatic distance. So you have D2. You have distance. Your arm can be extend and retract. It's variable. D is variable. Maybe 1 centimeter, maybe 100 centimeter. Depend to the sensor, the information from sensor. Sense go to theta. Theta also come from the encoder. 90 degree come from your robot design. So you design your robot, the position change 90 degree. Then you need to multiply. So from 0 to 1, some book they write 0 T1. Some book they write A. Before this, I follow the books of one of the book, they put A1. This book they write frame 0 to frame 1, something like that. 0 to 1, frame 0 to 1, this one lah. 0 to 1, sometimes they put join here. This is join, link or join. So 0 to 1, that means you have rotation matrix Z, and then you have rotation X. So after multiply these two rotation, so you get this matrix. And then from frame 1 to frame 2, at join 2 lah. Okay, you have only translation on Z. So translation on Z, that means you put your identity matrix 1, 1, 1, 1, and then you have Z. D2 translation. Then you need to multiply. To multiply, you must arrange this matrix from left to right. So that means this matrix on the left and this metric put on the right. So, and then you can multiply. So after you multiply, so you get this DH metric, a single metric. So that means 0 to 2, that means a metric 0 to 1 multiplied by 1 to 2. So you get this metric. If you want to imagine this coordinate is for gripper, normally they change from X and Y into NOA. NOA normally they give a special name for gripper lah. Gripper they exist X, Y, Z, but they give a name in NOA. NOA. So this is NOA. NOA or X, Y, Z lah. If robot arm normally they put X, Y, Z, but for gripper they put NOA. But this one is maintained lah. This is the position. For example, something like this. So I will give more examples, something like that. Something like this. So for example, if your robot arm that we do calculation here, if your robot arm rotate 120 degrees, so your arm going up, something like that, 120 degree, and then the arm extend 200 millimeter, so they extend to 100 millimeter. So you just plug this value, so your theta replace with 120 degree, and then your D2 replace with 200 mm. So you use this formula, D2 replace with 200, and cos 120, sin 120, sin 120, negative cos 120, and this also change sin 120, cos 120. So you will get this value. So this value. So when you get this value, so this is your position, coordinate, and this is your orientation. Your orientation. So any time your rotation, once your robot rotate, your theta change the value of your angle, so you will get a different coordinate. And then also when your arm extend or retract, so you will get the new coordinate. So combination of these two, you will get a new coordinate. So you always track your coordinate. Where is the position of your gripper, refer to your world reference frame based on this metric. So this metric you will put into your robot controller. Okay. I will give more example lah. After Raya, I will give more example. But during the Hari Raya, you try to find your example for your assignment. You must submit your assignment before second week. Second week, before second week. Because second week, I already conduct a quiz. So you must submit your assignment before quiz lah. Because I hope once you find your example in your assignment, you have idea how to calculate homogeneous transformation matrix. And also you have idea how to calculate DH method. One example only, one example calculation for homogeneous and one example for DH. So must be not same. So try to find your different example between each of the student.
Doktor,
Ya.
boleh atas sikit saya nak print screen yang metrik.
Tadi tak ni. Mana tak lagi? Saya kecilkan sikit bagi masuk.
Kecilkan sikit.
Betul.
Okay.
Tapi DH, your test will be maybe 4th week after raya lah. Minggu keempat lah macam tu. Selepas raya. Homogeneous information metric will be quiz 2nd week after raya. So you have 1 week lah. You have 1 week to study after raya. But example, I will give more on homogeneous DH method lah, because homogeneous is not difficult. Homogeneous is quite simple. So I give more example on DH method. Okay, Antena, any question tak? Kalau tak ada apa-apa, saya nak habiskan awal lah tadi. Sebab saya akan bagi lebih example lagi lah after raya. Semua example. So any question?
No, Doktor.
Tak apalah, you try to digest first. See the example that I give in the slide. And I also give the link, video link. You can download from my Google Drive for DH method. I'm not sure last time I give a DH method yet or not, but I will share a link again for DH method. I hope from that example in the video, you can learn better. Maybe you can understand better because it's explained more detail maybe from the video. So I hope you can be more understand on DH. Okay, kalau tak ada apa, so we meet again after